Hi! Today we are going to discuss intermolecular forces. After watching this video, you will be able to 1. Describe formation of London dispersion force, dipole-induced dipole force, dipole-dipole force, and hydrogen bond. 2. Explain the effect of polarizability, number of electrons, molecular mass, and shape of molecule on the strength of London dispersion force. 3. Understand the interaction of hydrogen bond in molecules, such as H2O, liquid NH3, and liquid HF, which give rise to hydrogen bond. 4. Identify the types of intermolecular forces that occur between molecules. You may hear the terms of intramolecular forces and intermolecular forces. Do you know the difference between them? Intramolecular forces are the attractive forces between atoms within a molecule. For examples, ionic bonding, covalent bonding, and metallic bonding. And these intramolecular forces tend to be strong. Meanwhile, intermolecular forces are the attractive forces between molecules. For examples, London dispersion force, dipole-induced dipole force, dipole-dipole force, and hydrogen bond. And these intermolecular forces are weak in comparison to intramolecular forces. Intermolecular forces are the forces that exist between molecules. Don't confuse these with intramolecular forces, which are the strong bonds that keep a molecule together. Intra means inside, so these are the inside forces in a molecule. Inter means between, so these are the forces between molecules. Intramolecular forces are weaker than intramolecular forces but still very important. The two intermolecular forces we are talking about in this video include dipole-dipole and ion dipole. There are 4 types of intermolecular forces. 1. London dispersion force. 2. Dipole-induced dipole force. 3. Dipole-dipole force. 4. Hydrogen bond. London dispersion forces, dipole-induced dipole force, and dipole-dipole force are usually called van der Waals forces, after the Dutch scientist Johannes van der Waals, who first attempted to explain them. All these intermolecular forces are electrostatic in origin and result from mutual attraction of unlike charges and the mutual repulsion of like charges. Polarizability is a measure of the ease with which the electron cloud in an atom or molecule is distorted. The higher the polarizability of atom and molecule, the easier instantaneous or induced dipoles can be formed. In general, as the number of electrons in the atom or molecule increases, the size of electron cloud in the atom or molecule also increases. A larger electron cloud is easier to distort, and the instantaneous or induced dipoles are easier to form. Therefore, atoms and molecules with large electron clouds experience stronger London forces than atoms and molecules with small electron clouds. The stronger the London forces, the higher melting and boiling point of a substance. London dispersion forces occur between nonpolar molecules. The force also occurs between noble gas atoms. All noble gas atoms and nonpolar molecules experience London dispersion forces because of the motion of their electrons. The process of separation of center positive and negative charge in a nonpolar molecule is called polarization. The molecule with a temporary dipolar arrangement of charge resulted is called molecule with instantaneous dipole, such as shown in the picture, due to the continuous movement of the electrons. The dipole dipoled is called instantaneous dipole because it lasts just a tiny fraction of a second. In the next instant, the motion of electrons causes non-symmetrical distribution of electrons throughout the molecule, but in a different location. And the molecules has a new instantaneous dipole and so on, such as shown on this picture. Although instantaneous dipoles are short-lived, they can affect the electron distribution in the neighboring nonpolar molecules. the temporary dipole develops in the effective molecule is called an induced dipole, as shown in this figure. This phenomenon leads to intermolecular attraction known as instantaneous dipole-induced dipole force, or London dispersion forces, or simply London forces. The strength of London forces depends on polarizability of atoms and molecule, number of atoms in a molecule, and the shape of the molecule. The effect of the number of electrons on boiling point can be seen if we compare the boiling point of the noble gases group 18 and the halogens group 17 as shown in table 1. Going down group 18, noble gases group, the higher the number of electrons, the larger the size of electron clouds surrounding the atom's nucleus. The higher the polarizability of electron cloud, the easier instantaneous or induced dipoles will form. The stronger the London forces, the higher the boiling point of the noble gases. Increasing the number of electrons in atoms and molecules is always followed by increasing atomic and molecular mass. Therefore, the strength of London forces increases with the increase of atomic mass, molecular mass, and also the orbital they are in. For molecules containing the same types of elements, the strength of London forces increases with increasing the number of atoms. This is illustrated by the boiling points of some linear hydrocarbons such as given in Table 2. Increasing the number of atoms in the hydrocarbon increases the size of electron cloud. The electron cloud is easier to polarize. Instantaneous or induced dipoles are easier to form. The London forces become stronger and the boiling point of the molecules become higher. Molecular shape affects intermolecular attraction. For examples, molecules of N-pentane make more contact with each other than do neopentane molecules. Because the elongated N-pentane molecule is more polarized than is the compact neopentane. Thus, N-pentane has stronger intermolecular attractive forces and therefore a higher boiling point. Dipole-induced dipole forces occur between polar and nonpolar molecules. The permanent dipole in a polar molecule can affect the electron distribution in a neighboring nonpolar molecule and induce a temporary dipole in the nonpolar molecule. This temporary dipole is also called induced dipole. This phenomenon leads to intermolecular attraction and the force involved is called dipole-induced dipole force. Formation of this force is illustrated in the figure. Dipole-dipole forces occur between polar molecules because polar molecules have permanent dipole moment. Polar molecules have separated centers of positive and negative charge. Because opposite charges attract, polar molecules tend to line up so that the positive charge of one molecule is near the negative charge of another molecule. In the liquid state, molecules move freely, so the alignment is not perfect. Nevertheless, there is still a net attraction between polar molecules as illustrated in figure. This kind of molecular attractive force is called dipole-dipole forces. The strength of dipole-dipole force depends on the dipole moments of the molecules. The greater the dipole moment of a molecule, the more polar the molecule. The more polar the molecule, the greater the strength of dipole-dipole forces. For molecules of approximately equal mass and size, the strength of intermolecular attractions increases with increasing polarity. This trend can be observed in this picture. Very strong dipole-dipole interactions are seen among molecules in which hydrogen is bound to highly electronegative atom, such as nitrogen, oxygen, and fluorine. Two factors account for the strength of these interactions are the great polarity of the bond, NH, OH, or FH bond, and the close approach of the dipoles due to the very small size of hydrogen atom. Because dipole-dipole interactions of this type are so unusually strong, they are given a special name, hydrogen bond or hydrogen bonding. Since the hydrogen bond is always longer than a covalent bond, the hydrogen bond is always weaker than the covalent bond. Hydrogen bonds can occur when an H atom is bonded to an N, O, or F atom due to the high electronegativity. Thus, HF, HO or HN bonds in one molecule can form hydrogen bonds with an F or N atom in another molecule. Several examples of hydrogen bonds are shown in the figure. In the liquid state, for example, hydrogen bond occurs in water, as shown in this picture. In liquid water, each water molecule forms 4 hydrogen bonds with its 4 surrounding water molecules. 2 hydrogen bonds are formed through 2 hydrogen atoms, and 2 others are formed through 2 its lone pairs. The H bond constantly breaks and reforms. Ion dipole forces act between an ion and a polar molecule. Remember that an ion is an atom that has gained or lost 1 or more electrons and therefore has a negative or positive charge. A cation is an atom that has lost a valence electron and therefore has more positive protons than negative electrons, so it is positively charged. An anion is an atom that has gained a valence electrons and is negatively charged. So, knowing that a dipole molecule has a slight charge on either side and that ions have charges, either negative or positive, you can understand how these would bond together. Cations would be attracted to the negative partial charge of a polar molecule, and anions would be attracted to the positive partial charge. London dispersion force is attraction between 2 instantaneous dipoles, and it happens between polar and nonpolar molecules. Here is the diagram. These are the weakest intermolecular forces, and it increases in strength as molar mass increases. Dipole-induced dipole forces are the attraction between polar and nonpolar molecules by disturbing the arrangement of electrons in the nonpolar species. They occur between the polar molecules having permanent dipole and the molecules lacking a permanent dipole. The diagram shows the process of induction between polar and nonpolar molecules. It is a weak intermolecular force compared to dipole-dipole force. Induced dipole moments depends upon the dipole moment present in the permanent dipole and the polarizability of the electrically neutral molecule. Dipole-dipole force is the attraction between 2 permanent dipoles, and it happens between polar molecules. The strength of this force is medium, stronger than London dispersion forces and dipole-induced dipole forces. This force is stronger when molecules are closer. Hydrogen bond is attraction between molecules with NH, OH, and FH bonds and occurs between extremely polar bonds with very strong dipole-dipole force. This is the stronger forces compared to others. It is called hydrogen bond, but remember, it's not a chemical bonding like covalent, ionic, or metallic.